functions, transformations, exponential functions. So as with our quadratic and our cubic, we have the exact same four transformations that are going to take place. So again, the graph is going to either move vertically up or down the y-axis, horizontally left or right on the x-axis, reflected in the x or the y-axis, and then be multiplied by a number that is going to change the graph by stretching it. So if we look at our first transformation, so same as always, if it's the function plus or minus a number, then what's going to happen is that the graph will move up or down the y-axis. If we add a number to the function, then the graph will move up the y-axis by that number of units. If the graph moves down the y-axis, then it's the function minus the number. So if we look at this example here, we can see we have f of x is equal to 2x. So the blue graph is our original function. And if we look at g of x is 2 of x plus 4. So basically what that's telling us is that g of x is 2 of x, which was the function f of x, plus 4. So in other words, what we're doing is we are adding 4 to all of the y coordinates. So all of the x coordinates remain the same, but just the y coordinates increase by 4. So if we wanted to find what was y equals 2 of x here, we can see the green graph. And if we want to know what is y is equal to 2 of x plus 1, well, what that means is that y is the original function plus 1. In other words, we would be adding 1 to the y coordinates. So what I can do is pick a couple of points on my graph. So we could go out to 0 and up to 1. I could go out to 1 and up to 2. I could go out to 2 and up to 4. And I could go out to 3 and up to 8. And that would give me enough coordinates then to sketch my new graph. So what we would have is our original function is 0, 1, 1, 2, 2, 4, and 3, 8. And then my new coordinates, well, I take my x and my y. My x is going to stay the same, which is 0, and my y coordinate increases by 1. So 1 plus 1 would be 2. Then it would be 2 plus 1 is 3, 4 plus 1 is 5, and 8 plus 1 is 9. So I can then sketch my new coordinates on my graph to get the shape of the graph. And then we would sketch our graph after we've plotted our points, and we can see the whole graph has just moved up the y-axis by 1. And the same can be done in reverse. If you want to identify what the transformation is, pick several points along your graph and then see what has happened. Has the x value changed, the y value changed, and how have they changed? So the second one is where the graph is going to move along parallel to the x-axis. So if we are adding something to x, then the graph shifts to the left by that number of units. And if it's f of x minus a, then the graph moves to the right a units. So in other words, our y coordinates will stay the same, and it's the x value that is going to change. So the x coordinate will change. So we can see here, if we have y equals 2x, then y equals 2x plus 1. Well, it's x plus 1, which means the graph moves left 1 unit. And here we have the green one is 2x minus 1. So what happens is the graph moves right 1 unit. So how would we go about picking those points? Well, again, if I select my points from my graph, and if we were to say look at 2 of x plus 1, then we know that the graph is going to move left. So therefore the x-coordinate is going to change by 1 unit. So if it's moving left, then it's going to be the x-coordinate minus 1. So we write down each of our points from the original graph. So again, taking the same points as the last time, 0, 1, 1, 2, 2, 4, and 3, 8. And this time, rather than changing the y-coordinates, we're changing the x-coordinates. So if I'm subtracting 1 from each of my x-coordinates, I'm going to have 0 minus 1, which is minus 1, 1. So my y values are all staying the same. 1 minus 1 is going to be 0. 2 minus 1 is 1. 3 minus 1 is 2. So we have our new points. So we plot them on our graph and then sketch our graph. And we make sure that we label our new graph. So this one here in blue is y is equal to 2x to the minus 1. So what we can see is that each point has shifted left. Where if we go back to the previous one, each point has gone up 1. And I forgot to label that one actually. So the red is y equals 2x plus 1. Okay, so the third transformation then is where we're going to get a reflection in the x-axis and the y-axis. So the graph will be reflected in the x-axis when the function is multiplied by minus 1. So in other words, the x value will stay the same, but the y value will be multiplied by minus 1 when it's reflected in the x-axis, as we can see here with e to the x and minus e to the x. Where if the graph is reflected in the y-axis, then the y value will stay the same and the x value gets multiplied by minus 1. So here we have the red graph is e to the x, whereas the blue one is e to the minus x. So if we do the same here for y equals 2 to the x, so again, if we take the same points as we've been using in each of our examples, then we have out to 0, up to 1, out to 1, up to 2, out to 2, and up to 4, and out to 3, and up to 8. And if we do the graph of y equals minus 2 to the x, then what's going to happen here is we are multiplying the original function by minus 1. So that means that our y values are going to change their sign. So therefore, each of these values, the x will stay the same, but the y will change its sign. So we have 0, minus 1, 1, minus 2, 2, minus 4, and 3, and minus 8. So again, what we can see is that each of our points have moved down. So they've been reflected around that x-axis. So if we were to do the same then with y equals 2 to the minus x, then what happens is the x values change their sign. So for the x values change the sign, we have 0, 1, minus 1, 2, minus 2, 4, and minus 3, 8. So all the y values remaining the same, only the x values changing their sign. And then if we sketch our graph, then we can see that each of our points have now been reflected in the y-axis. The only one that stays the same is 0, 1. And again, we can actually see that that graph there, 2 to the minus x, is actually the same as saying a half to the x, which we can see is our exponential decay. Okay. So the last one then is where we multiply by a number. If the number is a whole number, then the graph is a whole positive number, then the graph is going to lie above it. And if the number is a fraction, then the graph will be below the original graph. So we can see here the blue one is e to the x, whereas the red one is 2e to the x. So in other words, all of the y coordinates will have doubled. So therefore it's going to be above the blue graph. Where if we look at a half e to the x, well, all of the y coordinates will have halved and therefore will lie below the blue graph. So it's moving further away from the y-axis. So if we do the same here with y equals 2 to the x, so if we work out our sketch for y equals 3 times 2 to the x, well, what this means is that the y values will be multiplied by 3. So all the x values stay the same, but the y values are the ones that are going to change. So again, I'm taking my same 4 coordinates, easy to stick with the same ones. So we had 0, 1, we had 1, 2, we had 2, 4, and we had 3, 8. And I'll always select the points that are the easiest to read off the graph, the ones that I'm not guessing or approximating what they are. So always look for the easiest points to choose. So again, it's our y value that's changing. So we're multiplying the y values by 3 here, because the original function was 2 to the x. So if y is equal to 2 to the x, then our new function is going to be 3 times those y values. So that is going to give us 0, 3, 1, 6, 2, 12, and 3, 24. So if we plot our new points and we get our new graph, so we can see as we multiply by a whole number, the graph increases at a much faster rate. So again, we can see each of the y values are jumping much, much higher for each value that we increase by. Okay, so let's have a look at our books. And you're going to do page 51, question 15 to 22. So 15, 16, and 19, the graphs are already sketched for you, so you just have to identify from the graphs. 17, you'll have to do a rough sketch, and 18 as well. And then 20, 21, and 22, your new function form is described to you, and you have to write down what would the new function be. So in other words, if the graph is moving left or right or up or down by 1 unit or 3 units, then how would you describe that as a function?